Hey guys, Mr. Mannix here, and welcome to our first recorded lecture. This lecture is on kinetic energy. So, what is kinetic energy? Kinetic energy is the energy of movement. Anything that has mass and is moving has kinetic energy. So that could be these steel balls, which are swinging and colliding with each other. It could be this runner running down the road. It could be this child in the sled going down the hill. It could be the wind that is blowing through and moving these windmills, or it could be the windmills themselves that are actually turning and have kinetic energy. That doesn't mean this is the only type of energy all these things have, but they all have kinetic energy because they're moving. Finally, thermal energy is also a type of kinetic energy. When you heat something up, what actually happens is that the atoms in this substance start moving faster. As they start moving faster, the thermal energy of this thing increases, and the kinetic energy of this thing increases. In fact, temperature is just a measure of the average kinetic energy of an object. So what affects how much kinetic energy something has? There's two things that affect it that most of us can inherently understand. One is how big it is, something's mass. So a more massive object has more kinetic energy than a less massive object that's moving at the same speed. So a football player who weighs 250 pounds has more kinetic energy than a 200-pound football player running at the same speed. And the other one then is your speed. How fast are you moving? The faster you're going, the more kinetic energy you have. But do these two have the same effect? Does mass have the same effect as speed? Well, let's look at a couple graphs. So this is a graph of the kinetic energy of an object. Kinetic energy is measured here on the y-axis, and the speed in miles per hour is measured on the x-axis. So let's look right here. At a speed of about 52.5 miles per hour, we have a kinetic energy of 0.1 kilowatt hours. So let's double our speed and see what effect that has on our kinetic energy. So double 52.5, 52.5 times 2 is equal to 105. So 105 is right here. And if we find our kinetic energy, it's 0.4. 0.4 is 4 times as big as 0.1. So while our speed only doubled, our kinetic energy quadrupled. Let's look at one more example. If you look at 40 miles per hour right here, okay, I'm looking at this and that's pretty close to maybe 0.06 kilowatt hours as far as kinetic energy goes. What if we double our speed to 80 miles per hour? Okay, that's about maybe 0.24 kilowatt hours. 0.06 times 4 is 0.24. So again, it quadrupled. So actually, kinetic energy goes up as a square of the speed. Okay, so if speed doubles, then 2 squared equals 4. Kinetic energy quadruples. If speed triples, then 3 squared is equal to 9. Kinetic energy would go up 9 times. If you were to quadruple the speed, go 4 times faster, then 4 squared equals 16. You'd have 16 times as much kinetic energy. But what about mass? So you notice in kinetic energy versus speed, this is a curved line, which means that it goes up, it's not linear, it goes up exponentially, as we saw here as it was squared. But in the mass versus kinetic energy graph, this is the mass in atomic mass units of atoms down here and kinetic energy on this side. This is linear. So at a mass of 1,000, we have a kinetic energy of 1,000. What if we double the mass to 2,000? Now we have a kinetic energy of 2,000. So as the mass doubled, the kinetic energy doubled. If the mass triples 1,000 to 3,000, the kinetic energy goes from 1,000 to 3,000. So, as mass doubles, kinetic energy doubles. As mass triples, kinetic energy triples. We can put that all together in one equation. That equation is kinetic energy equals 1/2 mass times velocity squared. Okay, so we can see that mass, because it did not, if mass doubles, kinetic energy doubles, there's no exponent on this one. Velocity, there was an exponent. It's squared. So, what will cause a larger change in kinetic energy? Increasing an object's mass or increasing its velocity? This problem asks us to calculate the kinetic energy of a 2 kilogram object going 4 meters per second, or the kinetic energy of a 4 kilogram object going 2 meters per second. So, kinetic energy is equal to 1/2 mass times velocity squared. Therefore, kinetic energy is equal to 1/2 times 2 times 4 squared. Kinetic energy is equal to 0.5, I'm typing this into my calculator as we speak, times 2 times 4 squared is equal to 16 joules. Kinetic energy is measured in joules, by the way. Alright, what if we have a 4 kilogram object doing 2 meters per second? So kinetic energy, this is how I'd show my work again. I'm having trouble with my pen here, just a sec, equals 1/2 mass times velocity squared. Therefore it equals 1/2 times 4 times 2 squared. And finally we wind up with 0.5 times 4 times 2 squared equals 8 joules. So, having a larger speed has a larger effect than having a larger mass. Okay, so again, velocity has a larger effect than mass on something's kinetic energy. Alright, so the formula for kinetic energy is kinetic energy is equal to 1/2 mass times velocity squared, and kinetic energy is measured in joules. What is a joule? Well, if you look at this, kinetic energy equals 1/2, which has no units, times mass, which is in kilograms. And just a second, I'm having more trouble with my pen, so I'm going to pause you really quick. Okay, let's try this again. What is a joule? My pen's still acting up a little bit, but hopefully we'll be able to make do. Kinetic energy is equal to 1/2, which has no units, times the mass times the velocity squared. So mass is measured in kilograms, and velocity is measured in meters per second, and meters per second is squared. So a joule is effectively a kilogram meter per second squared. Let's write this out. A kilogram meter per second squared. That's what a joule is, and they didn't want to write that out every time, so they just gave it a new name and they called it a joule. Alright, so let's practice a few calculations with kinetic energy. I'll show you how to do one of each type, and that will be the end of this video. So a 1,200 kilogram vehicle is traveling down the road at a velocity of 25 meters per second. What is the vehicle's kinetic energy? So we write down the formula. We know that kinetic energy is equal to 1/2 mass times velocity squared. Okay, so this type of problem is one that gives us the mass and the velocity and asks us to calculate kinetic energy. So we plug our numbers in. Kinetic energy is equal to 1/2 times our mass of 1,200 kilograms times our velocity of 25 meters per second, which must be squared. Alright, we type this into our calculator. 1/2 times 1,200 times 25 squared equals 375,000. 375,000 joules. okay, or kilogram meters per second squared. So what are the keys to solving these problems? Make sure that what we're putting in here is the mass and not a speed or an energy, and that the value we're putting in here is our speed. So again, look for, this is a mass because it's in kilograms. This is a speed because it's in meters per second. If it had given us joules, then that would be a kinetic energy. Alright, second type of problem. Now they give us a kinetic energy and a mass but no speed. A 5-kilogram bowling ball is rolling down the alley with a kinetic energy of 75 joules. What is the bowling ball's velocity? So again, what do they give us? Mass and energy, but they don't give us, and what they're asking for is the velocity. So kinetic energy equals 1/2 mass times velocity squared. I plug in what I know. I know the kinetic energy is 75 joules. So that's equal to 1/2. I know the mass times 5 kilograms times the velocity squared. And I don't know the velocity. So I'm going to multiply through. 75 joules is equal to 1/2 times 5 is 2.5 times the velocity squared. I'm going to divide by 2.5. $75 divided by 2.5 is equal to 30. So 30 is equal to velocity squared. Therefore, velocity is going to equal the square root of 30. Sorry about the pen there. But I take the square root of 30 and I get 5.477 or 5.48. So velocity is equal to 5.48 meters per second. Alright, last problem. A football player is running at a speed of 10 meters per second and has a kinetic energy of 5,000 joules. What is the football player's mass? So what do they give us? They give us the energy and they give us the speed, but now they don't give us the mass, and we need to calculate this football player's mass. So I'm going to write out my equation. Kinetic energy equals 1/2 mass times velocity squared, okay, which is equal to 5,000. Kinetic energy is 5,000 joules, is equal to 1/2 times mass, which I don't know, times my velocity squared, so times 10 squared. Therefore, 5,000 is equal to 1/2 times the mass times 100, because 10 squared is 100. Again, sorry about the pen. Therefore, 5,000 is equal to 1/2 times 100 is 50 times the mass. So I divide both sides by 50. And the mass is going to equal 5,000 divided by 50, which equals 100. So the mass is equal to 100, or 100 kilograms is my answer. Alright, that's it for this video. Check back in for the next one.